Welcome to NM's Arena. In this video, let us discuss how to find the inverse of a matrix. The inverse of a matrix means reciprocal of a matrix. Suppose B matrix is the reciprocal of A matrix, then A into B is equal to I. That is, when we multiply a matrix with its reciprocal matrix, we get the identity matrix. So, if B is the reciprocal matrix of A matrix, then A into B will be an identity matrix. In the same manner, B into A will also be an identity matrix. Now we are going to see how to find the reciprocal matrix of a particular matrix. That is called inverse of a matrix. And now let us see the formula for finding inverse of a matrix. Inverse of matrix A is equal to 1 divided by determinant of A into Adj A. So, for the purpose of finding the reciprocal of a matrix or the inverse of a matrix, we have to find the determinant of that matrix and the adjoint of that matrix. And we have to put it in this formula. 1 divided by determinant of A into Adj A. And now let us take an example to find the inverse of a matrix. Here we are going to find inverse of matrix A. The matrix is given as matrix of 3, 5, 7, 2, minus 3, 1, 1, 1, 2. First of all, we have to find the cofactors of all the elements in this matrix. So alpha 1 1 is equal to minus 1 raised to 1 plus 1 into determinant of minus 3 1 1 2, that is equal to minus 7. We have already explained how to find the cofactors of a matrix in another video. And then the next element alpha 1 2 will be minus 3, then alpha 1 3. Cofactor of element in the first row, third column will be 5. And next, when we come to the second row, alpha 2 1. Cofactor of element in the second row, first column will be minus 3. And alpha 2 2, that will be minus 1. And alpha 2 3 is 2. And in the same manner, we have to find the cofactors of the elements in the third row also. Alpha 3 1 will be 26, alpha 3 2 it will be 11, and alpha 3 3 is minus 19. So, we have obtained all the cofactor values. That is, we have found the cofactors of each and every element in the matrix. The next step is to put these values in the right position inside the matrix. The cofactor of first row, first column element should be put in that position itself. These are the values of cofactors calculated, and it is put in the right position. Alpha 1 1 is put in the position of A11, alpha 1 2 is put in the position of A12. Now, to find the adjoint of this matrix, we have to calculate transpose of this matrix. This matrix is the cofactor matrix. Since all the elements in this matrix are formed using the cofactors of the elements in the original matrix A, this matrix is called cofactor matrix. So we have to find the transpose of the cofactor matrix. For finding the transpose of a matrix, we have to change the rows into columns and columns into rows. So Adj A is equal to matrix of minus 7, minus 3, 26, minus 3, minus 1, 11, 5, 2, minus 19. That is the first row here, minus 7, minus 3 and 5. That is converted into first column here. The second row here is converted into second column here. Third row is changed into third column. So we have changed all the rows into columns and columns into rows. Now let us look it into the formula to find inverse of A. That is 1 divided by determinant of A into Adj A. Since we have already computed Adj A, next we have to calculate determinant of A to be applied in this formula. And so we are going to find the determinant of 357 minus 31112. So we are taking the first element in the first row, removing all the other values in the first row and first column in which this element lies, and then multiplying that with the determinant of the remaining elements, we get it as 3 into determinant of minus 3112. Then taking the second element in the first row, and the second element will be having a minus sign. So minus 5 into determinant of 2112. Then the third element plus 7 into determinant of 2 minus 3 1 1. Detailed explanation of how to compute the determinant value is already explained in the previous video. Then the next step is 3 into minus 3 into 2 minus 1 into 1 minus 5 into 2 into 2 minus 1 into 1 plus 7 into 2 into 1 minus 3 into 1, that is equal to 3 into minus 6 minus 1 minus 5 into 4 minus 1 plus 7 into 2 plus 3, that is 3 into minus 7 minus 5 into 3 plus 7 into 5. So the determinant value of this matrix is minus 1. Hence, we got all the elements to be applied in the formula. We got Adj A as well as determinant of A. Now let us apply it in the formula. So inverse of A is equal to 1 by minus 1. Minus 1 is the determinant of A. That into the Adj A matrix. Now 1 by minus 1. So we have to multiply the whole Adj A matrix with minus 1. That will change the signs of all the elements in the matrix. And the matrix will be like this. Matrix of 7, 3, minus 26, 3, 1, minus 11, minus 5, minus 2, 19. So this is the inverse of matrix A. So that is how we find the inverse of a matrix. Thank you for watching this video. For more videos, subscribe the channel.